number 2 students. We've got another exciting episode for you today. Chapter 3.2, the graph of y equal mx plus b. Now, I know you guys know it's a line, and I know it's a line too, but let's just look at how we can kind of quickly graph this. So, for one example, I've got y equal to 4x plus 7. And I'm going to graph this how I graph any function, which is just pick a few points and connect the dots. So, the easiest points to put in are probably x is 0 and 7 comes out, and x is 1, then 4 comes out. And since I know it's a line, I only need those 2 points. So sketch those points on the graph, connect the dots, and voila, we have our line. It's that easy. All right, well, you may ask, but wait a minute. What if the equation isn't in the y equal mx plus b form yet? Well, have no fear. I'm going to go through an example. So here we have graph the line 2y equals minus 3x plus 16. So I really want to be able to plug in points here, but to do that, I need to get y by itself first, which I can just do by simply dividing by 2 on each side. As long as I do it to both sides, the equality stays the same. And I get minus 3 halves x plus 16 over 2, which 16 over 2 just simplifies down to plus 8. Okay, now I can start picking some points for my graph. X is 0 is always a nice easy one. So when x is 0, let's see, negative 3 halves times 0 is 0, plus 8 is 8. Remember, 8 is also the y-intercept, so... And then I wouldn't plug in 1 because 1 times negative 3 halves is kind of awkward, but 2 is good because 2 is going to cut with the 2 on the bottom, and I'm going to get negative 3 plus 8, so 5. All right, so let's get these 2 points on there, 0, 8, and then I got 2 for the x, 5 for the y. And that's all I need. I'm going to go ahead and connect those 2 points, and I got my line right there. So the moral of the story is, if y is not by itself, the first thing you should do is get y by itself, and then you can just plug in 2 points and connect the dots. One thing to notice is the slope of this line is negative, and sure enough, we have a negative sloped line, right? So one thing to just check yourself on the graphs is, for example, this first one, the slope was 4. Remember, it's the number times the x. It's a positive slope, so it should be an upward sloping line. So just keep an eye on that. It'll just prevent you from, if you plugged a number in wrong, you'll catch it if you just kind of take a look at the slope. All right, now what about horizontal lines? What do those look like? So that would be something like graph the line y equal to 2. And also go ahead and identify domain and range. You can think about what domain and range were for those first 2 examples. But let's just look at this one here. So the line y equal to 2, it's a pretty boring function. Basically, y is always 2, meaning it doesn't matter what x I put in, it's always going to spit out 2. So if I put in x is 0, guess what? It comes 2 comes out for y. If I put in 1, 2 comes out. If I put in negative 1, 2 comes out. It doesn't matter what I put in for x, I always get 2. So if we put some of those points on the graph, 0, 2, 1, 2, negative 1, 2, we see that if we connect those dots, it's going to be a horizontal line, and that's why the horizontal line is y equal to some number. It's just going to be a horizontal line at that number. And something to note is the slope of this line is 0, and we don't have any, we don't have any x, so there's no number times the x. So that all kind of lines up with what we would expect. So the domain is going to be all real numbers because we can put in any x we want. We can put in any input. And the range, go ahead and pause and think about it. Yeah, the range is the possible y values, and I can only get one y value, 2. So the range is literally just one number, 2. Okay, the last thing we're going to talk about in this section is parallel lines. So I'm going to graph a couple lines here. Let's look at y equal 3x minus 7. And let's also look at y equal 3x plus 4. Okay, so The spoiler is that these are parallel lines, but let's just take a look and graph at them just to convince ourselves that they are. So I'll graph this first one, y equals 3x minus 7. I'll just choose a couple x's, get a couple y's. So x is 0, y is negative 7, and when x is 1, 3 times 1, 3, minus 7, negative 4. So I've got a couple points, 0, negative 7, 1, negative 4. And I just need those 2 points. And I'm going to connect the dots, and I've got my first line there. Let's see. I'm going to do this line in my fancy green color. If I can get this ruler to line up here. You wouldn't believe how hard a touchscreen ruler is to use, okay? It's harder than it looks. Don't make fun of me. Okay, so there we go. I've got the green line there, and you know what, why don't I just put this table in green as well, just to emphasize that that's what I use to graph this green line. And the second one, y equal to 3x plus 4, I'll go ahead and graph in blue. So I'll get a couple points. X is 0, y is 4, and x is 1. 3 times 1, 3, plus 4, 7. So I got 2 points. That's all I need. I'm not going to get any more than I need. Why would I? And I have 0, 4, and I have 1, comma 7. And I'm going to take out my ruler again here and try and line this up. And let's see here. It's a little more. Okay, and I'm going to connect the dots with my blue line. Now, if I did this on graph paper where my axes, like my intervals, were evenly spaced, you would see that these are parallel lines. It doesn't look parallel because I just kind of did a rough estimate, but they are parallel lines. They're supposed to be, and they would be if I did it on graph paper. One thing to notice is if we look at the slope of both these lines, the slope is both 3, right? And it's not a coincidence. If you have the same slope, guess what? You are your parallel line. Because if you think about it, if you have the same slope, that means that you're increasing at the same rate. So that's something to keep track. That's something that can be handy just to know. So we have a theorem. Usually when something is quite handy and we've shown it to be true in every case, we call it a theorem. So in this case, we have if two lines have the same slope, well, what do we know about those lines? Well, we know that they're parallel lines. So again, if you have the line in the form y equal to mx plus b, and the m is the same for two different lines, they are parallel lines. And it goes the other way too, that if the lines are parallel, they have to have the same slope. So it works in either direction. So if you have two non-vertical lines, because a vertical line doesn't have a slope, it's undefined. So we're going to throw that out. But basically, if two non-vertical lines are parallel, then they're going to have the same slope. All right, that's it. We'll see you in the next lesson. Thanks so much.